Okay, so in this video, I will explain the stacking sequence of FCC and HCP to visualize the stacking sequence. So we start with HCP first. So with HCP, as what we learned from module 2, lesson 2, the HCP will have one plane at the bottom with 6 atoms at each corner and one in the middle. So it will, if you want to visualize it, it will look like this. So we have 1, 2, 3, 4, 5, 6 with one in the middle, 1, 2, 3, 4, 5, 6 with one in the middle. And we have 3 atoms on top of that plane. So it will be sitting like that. And then we will have the one at the bottom here repeat again on the top. So it has exactly the same position where the atoms is going to sit. So that's going to look like this. So if we look at the stacking sequence, this is number 1, 2, back to number 1. So if we name it as A, B, that will be A again. So A, B, A. So that's the unit cell of HCP and its stacking sequence. We have plane, this plane, and then we have in the middle and repeat again. Now let's have a look at FCC. This is going to require your imagination of the unit cell on top at the right and in front of the cubic. So let's have a look at the HCP unit cell. So this is the HCP unit cell with 8 atoms at each corner of the cubic and 1 atoms on each face of the cubic face. So there will be 6 atoms for 6 of the cubic face. All right, so if we want to imagine its stacking sequence, so we've learned from module 2 lesson 2 that HCP and FCC has the same atomic packing factor, which is 0.74, and it has each of the atom has the same number of neighboring atoms, which is 12. So they both have the same coordination number as well as they have the same APC, the atomic packing factor. That difference is the way the atoms stack together. So for HCP, the stacking sequence is what I have explained to you just then. If we want to imagine the FCC stacking sequence, let's have a look first at the 2 plane here, the plane, the family plane 1, 1, 1. I have here a cubic, and I've used this elastic band to represent the stack at the plane 1, 1, 1. So this is plane 1, 1, 1, and this is another one. So if you look at that, each of these plane has 6 atoms associated with that plane. So there will be 1, 2, 3, 4, 5, and 6. For the inverted one is 1, 2, 3, 4, 5, and 6. So I will have that represented by this sphere. So there's this plane here. That's going to be how the atoms is going to be represented. Whereas, so it's like a triangle. And for this one here, the other plane, it's inverted triangle. So that's going to be the plane. But that's not enough. We still have the 2 corner atoms, one at the origin and one at the top corner. So if we have one here and we have one here. So that's how the unit cell of FCC is going to look like. I have the one here that I've already glued together, so let's have a look at that. Okay, so this is the top corner, this one, and that one is the origin, right at the origin there. And if we just focus our attention to this plane here, this is this plane. So we have 1, 2, 3, 4, and 1 in the middle. 1, 2, 3, 4, and 1 in the middle. So that's our unit cell. Okay, now let's have a look at its stacking sequence. So just focus on your attention not to the plane 1, 1, 1, the 1 atoms at that top corner there, the one that we add after we stack our plane 1, 1, 1. Just this one. If you imagine that there is another plane on top of this, there's another plane on top of this, because this unit cell is going to repeat itself over and over and over again. So there's going to be another one on top of this. This corner atom will have these neighboring atoms, because each of the face of the unit cell, of the cubic face on top, will have this going to be its bottom plane, and each faces will have one in the middle. So you will have another one there, sitting there like that, something like that. And the same with this unit cell here. If you have a new unit cell here, what's going to happen is that these atoms will be here, another atom will be sitting there for the bottom, for the top face, and then the face right here will also have atoms like that. The same again, imagine if you have something here, okay, just focus on these atoms. This unit cell here will have atoms there, and also it will have an atoms there. So it is not wrong if I say that atoms, this one, will have that 6 neighboring atoms look like that. I hope you can see that, okay, because of the atoms in the unit cell in front, unit cell on top, in front, and at the right. So it's not wrong if I said that one is going to have these many neighboring atoms surrounding it. Okay, that settles it. Let's go back to our plane 111. So this is our plane 111 for FCC. This is our plane, the other family plane. So that atoms that sit at the corner just then, the one that we established at the very beginning, is now going to be having that many atoms surrounding it. So the one at the bottom, that one at the origin, is also going to have the same, because this is repeating itself over and over and over again. So the one at the corner for the origin just then is also going to have the same atoms looking with the neighboring atoms. So if we look at the stacking sequence, the one here, the first stack, is repeating after these two planes. So we have A, B, C, and back to A. Okay, so I hope you can see that one. So if we want to visualize this the same as we visualized the HCP just then, so with HCP we said that we only have the 3 atoms in the middle. So just look at the middle part. So if we dismantle this, just focus on that middle part, and if I change that to this, so the middle part is inverted actually, and for the one on top, which is the other plane that was inverted, the middle 3 atoms is now a triangle. So that's a triangle, and back to the one at the corner just then. So now we can compare it to the FCC. You can see that this is A, B, C, and back to A. So that's the difference between the stacking sequence of HCP and FCC. All right, so that's about it. This will make a lot of difference when we learn about the slip plane. So when we learn about the slip plane, you can see that there is a huge difference between HCP and FCC. As for now, looking just at the unit cell, we've calculated the APC and we've calculated the coordination number. They're both the same. We've learned now that their stacking sequence are different, and this will make a lot of difference in terms of their mechanical behavior, because the number of slip system is going to be different. I hope you understand that. Thank you very much.